So we talked about factoring quadratics, but we can actually also factor cubics. And just like quadratics, there are some cubics that are factorable and there are other cubics that are not, or they're prime cubics. So we're going to talk about just a few of them, okay? And we're only going to talk about the ones that are factorable, except in two specific cases, okay? So one of the things that you should become really familiar with is a difference of squares, okay? So a difference of squares is just a squared minus b squared. So let's go back to quadratics for just a second. It's going to seem like what we say about quadratics is kind of out of place. It's not. You'll see why in a few minutes. So first of all, quadratics, we have a difference of squares. And a difference of squares would be in the form a squared minus b squared. Okay, and this factors to a plus b times a minus b. And if you don't see that right away, if we actually multiply this out, we get a times a, which is a squared. And then we get plus a times negative b, which is negative ab. Then we get plus b times a, which is also ab. And then b times negative b is negative b squared. And if you notice, this negative ab plus ab is the same thing as a squared minus b squared. So this is really useful to know how to factor in a squared minus b squared. So for example, if we have x squared minus 81, x squared is a perfect square, 81 is a perfect square. So when we factor it, it becomes x plus 9, x minus 9. So this only works when we have a difference of squares. If you're adding, then you can't do this, okay? Because there's no way that the middle term will cancel out the way that it does here. If we take another one, if we take x squared minus 9, this factors to x plus 3 times x minus 3. Okay, if we have, let's take something even more. Let's take 4x squared minus 16. Well, again, 4x squared is a perfect square. So the square root of x squared is x, and the square root of 4 is 2. So now we have 2x, and then 16 is also a perfect square. Its square root is 4. So we have 2x plus 4 and 2x minus 4. If we had 16x squared minus 9y squared. So this is also factorable. It's also a difference of squares. This would be 4x plus 3y times 4x minus 3y. So as long as we have perfect squares, we can, and a difference of perfect squares, we can factor it. Let's take one more. Let's say that we had 100. And instead of x and y, let's just use 100m squared minus, let's use minus 25 n to the 4th. Okay, so this one is a little bit more complicated, but we can see that they're still both perfect squares. So the square root of 100m squared is just 10m. And then the square root of 25n to the fourth is actually, square root of 25 is 5. And the square root of n to the fourth is actually just n squared. So we get 5n squared here. And then the key thing to recognize is that you're getting the same thing, right? The conjugate, this is a conjugate. And sorry, my parentheses did not come out here. This is a conjugate. Because that middle sign, right? Sorry about that. I don't know why that keeps stopping. Okay, that middle sign, that's the only sign that's changing, right? It goes from a plus to a minus. So these are conjugates of one another. A plus b and a minus b would be considered conjugates. Okay, so this is really helpful in knowing how this factors. Again, it's going to come up a lot when we do factoring cubics. Okay, let's go back to cubics then. So cubics also have a difference of squares. A difference of cubes. And this, you kind of would just have to remember. So this I just want to show you. It's not, I mean, it's great to know, but it's not especially important. It's just great to know that it can be factored. Okay, so difference of cubes can be factored. If we have a cubed minus b cubed, then what this turns into is a minus b. And then we're going to multiply it by a quadratic, and the quadratic is a squared plus ab plus b squared. Okay, and what this is going to do is it's going to cancel out middle terms where we have something squared or something raised to the first power, because we only want the cubes. And that's why the signs are opposites of one another, so that we get a plus and a minus. Okay. And if we just take an example, again, this is not super important, so I don't want you to get too caught up in it. But let's say, for example, that we have 64 minus b cubed. So for those of you who don't know, 64 is a perfect cube. 64, the cube root of 64 is 4. Okay, and your b here is just b. So we're just identifying what a and b are, so now it's just a plug and chug. So as your plug and chug, your a is 4, your b is just b here. So then you have 4 squared plus 4 times b plus b squared, which if we simplify, we could make that 4 squared just 16. Okay, if we take one more, just so that you get accustomed to what we're doing, 27 is a perfect squared, so perfect cube. So let's say we have 27 minus, let's make it 64 b cubed. Okay, so let's actually change this from a b to an x, just because I don't want to overuse the b. So here, your a is 3. The cube root of 27 is 3. And your b is just 4x, because the cube root of 64 is 4. And then the cube root of x cubed is just x. So again, this is just a plug and chug. So it's a minus b times a squared, which is 3 squared, plus a times b, so a times 3 times 4x, and then plus b squared, so plus 4x squared. And if we simplify this, we get 3 minus 4x. 3 squared is 9. 3 times 4x is 12x. And 4x squared is 16x squared. Okay, so it can be factored. And then there is a formula for the sum of cubes, which I'll write down here. We won't do any examples though, because again, it's a plug and chug. So you can't have a sum of squares, but you can have a sum of cubes. The formula for the sum of cubes is very similar. It's a cubed plus b cubed. And this becomes a plus b. And then times a squared minus ab plus b squared. Okay, so these signs in the middle over here are just the opposite. Since it's a sum of cubes, this we subtract. And it's a difference of cubes up here, so we add. Okay, so this is the cubics I'm not as concerned about, but the quadratics, I really want you to know the difference of squares. So what we're going to do is we're going to look at very specific cubics now. Okay, we're going to look at cubics where you can factor by grouping. Now you've actually done this. Okay, and where you've done it when you were doing factoring of quadratics, when your a was greater than 1. Okay, you did a factor by grouping. So we're going to do exactly the same thing, but we're going to do it with cubics, and we're just going to do a bunch of examples. So we're going to, and I'm going to emphasize that not every cubic can you use factor by grouping. Okay, so let's just review the different steps. So the first thing that you're going to do is you're going to group the first two terms. And this is specifically for cubics, but it's very similar for any other polynomial. You would group two terms together simultaneously. So here you're going to group the first two terms. And the last two terms. And what I'll do is I'll simultaneously go through an example so that you see what we mean as we go. So let's say that we had x cubed minus 2x squared minus 9x plus 18. Okay, well, if we're grouping the first two terms and the last two terms, what we're doing is we're taking the x cubed minus 2x squared, we're grouping that, and then we're grouping the negative 9x plus 18. Okay, so this negative is included in the second group. The next thing that we're going to do is we're going to identify a common factor in each group. And I'm going to use the word separately, and the reason why I'm going to use that word is so that it's clear that we're factoring something different out of each of the two groups. And you're going to factor. Okay, so what does this mean? We're going to look at the first group and we're going to say, what is something that both terms have in common? So we can see that both terms have an x squared in common. So we're going to factor that out. And what we're left with is an x minus 2. So notice if we redistribute the x squared, we will get x cubed minus 2x squared. It's as if you're taking each term and you're dividing by x squared. Now we're going to do the same thing for the second group. So in the second group, we have a negative 9x plus 18. So there's a 9 that goes into both. And pull out the negative 2. If there's a negative here, the negative also. If there's a negative here, pull it out. So we have a plus, and we're going to pull out negative 9, which leaves us with an x minus 2. Okay, now notice, again, just like in the quadratics, we have an x minus 2 in both of these. That's what should happen. If it doesn't happen, then check to make sure that you didn't make a mistake. And if it If you didn't, and this happens, and this doesn't happen, then it means it's not factorable by grouping, okay? So the next thing that you're going to do is you're going to identify a common factor for each term. And that should be easy to identify because it's what's in the parentheses. And once again, you just factor. So we have an x minus 2 that's common to both terms. So x squared times x minus 2 is a term. We're going to factor out the x minus 2. And we're going to look at what we're left with. So in the first term, we're left with an x squared. And in the second term, we're left with a negative 9. Okay, so you can see here's where the x squared minus 9 came from, these coefficients here. And then the next thing that you're going to look for is a difference of two squares. So if you have a difference of squares, you don't always. Then you're going to factor. So if we look down here, x minus 2 is linear, so that's not going to be a difference of squares. But x squared minus 9 is a difference of squares. So x squared minus 9 factors 2x plus 3 times x minus 3. So this is where that difference of squares can come in really handy. Okay. And just as a side note, if we wanted to solve for the roots, you're going to set it equal to 0, and you're going to use that 0 property. So the same exact way that we solve for the roots when we have a factor quadratic. So in other words, we have x minus 2 times x plus 3 times x minus 3 is equal to 0. And the 0 property says, okay, well, if x minus 2 equals 0, then the whole thing equals 0. If x plus 3 equals 0, then the whole thing equals 0. And if x minus 3 is equal to 0, then the whole thing equals 0, which gives us a root of x equals 2, a root of x equals negative 3, and a root of x equals positive 3. And for a cubic could potentially cross the x-axis 3 times, up to 3 times. And this does. It crosses it at these 3 x values. Okay. Let's take a few more examples. So let's do x cubed plus 3x squared minus 6x minus 18. Okay. And we're going to do the same thing here. We're going to group these into 2 groups. So we have the first 2 terms. Notice factor by grouping works best when we have an even number of terms. The negative in front of the 6x goes into that second group. And we look in each group to see what both of the terms in that group have in common. So notice we look at the groups separately. X cubed plus 3x squared. We can see that they both have an x squared in common. So we're going to pull out an x squared. And then what we're left with is x, because x squared times x gives us x cubed, and then plus 3. And from the second group, we could pull out a negative 6. And once again, that's going to give us an x. And then this becomes a plus because we're pulling out a negative. So plus 3. And a good way to just double check is redistribute. If we redistribute the negative 6, then we do get negative 6x minus 18. And this is factorable by grouping because we have an x plus 3 in both of these. So now we're going to factor out the x plus 3. And what we're left with is x squared minus 6. Okay, so we're going to look for a difference of squares, but this is not a difference of squares. This is x squared minus 6. 6 is not a perfect square. And we're not going to solve for the roots in all of these, but I do want to show you what would happen in this case. Okay, so in order to find the roots, you do the same thing. You set it equal to 0, so we have x plus 3, and then times x squared minus 6 is equal to 0. So from the first one, we have x plus 3 can equal 0, or we would just write x squared minus 6 equals 0. And now we just solve each one. So from the x plus 3, we would just subtract 3 from both sides. We already know this, that that's going to give us x equals negative 3. And the x squared minus 6, we just have 2 steps. We're going to first add 6 to both sides. That's going to give us x squared equals 6. And then we have an x squared, so we have to do plus or minus the square root, right? So we're taking the square root of both sides, and once again, plus or minus, okay? So that leaves x equals negative 3, or x equals positive square root or negative square root of 6. And the square root of 6 can't be simplified, so these would be our roots, okay? And just like when we solve absolute value equations, it can be good to write our answer as a solution set so that it's very clear when we finished. So even here, write it as a solution set. So 2, and you can write it as plus or minus 3, or you could write these separately. Okay. Okay, let's take another one. The next one, I'd like you to try and pause the video, do it yourself, see if you can do it. And I actually just keep on doing that for the next few that we do. So we have x cubed plus 3x squared minus x minus 3. So once again, you're going to group it. So we're going to group the first 2 terms and the second 2 terms, and again, include the minus. You're not always going to have a minus. It just happens by coincidence that all of the examples I have minus in there. Okay. So once again, we look at the first group and we say, okay, x cubed plus 3x squared. We have an x squared that we could factor out. So you're always going to have an x squared that's going to be able to cancel out when you have this cubic, okay? So we have x squared, and we're left with x plus 3. Then we're going to look at the second group. So notice you can't really factor anything out, but there is a negative 1 here. So we can factor out a negative 1. And if we do that, we wind up with x plus 3. So we have an x plus 3 in both of these terms, so we're going to bring it out to the front. From the first group, we have x squared left over. And from the second group, we have a -1 left over. And we're going to look for a difference of squares. X squared minus 1 is a difference of squares. So this is just x plus 3 times x plus 1, x minus 1. Okay. Let's do 2 more. X cubed minus 3x squared minus 16x plus 48. Okay, and just keep in mind with example 3, our roots would be -3, 1, and -1. So -1 from here and +1 from here. So this one, we group our terms. So we have x cubed minus 3x squared, -16x plus 48. From the first 2 terms, we can take out an x squared, not surprisingly, leaving us with x minus 3. And from the second 2 terms, we can actually take out a -16, which leaves us with an x minus 3. X minus 3 can get pulled out, leaving us with x squared minus 16. And here, we can factor x squared minus 16. 16 is a perfect square. It leaves us with x plus 4 times x minus 4. Okay, let's do one more. And this time, the one that we do is going to have a value in front of the x cubed, which doesn't change anything at all. Please keep in mind, it doesn't even make it longer. Okay. So we have 4x cubed plus 16x squared minus 9x minus 36. So unlike the quadratics, okay, having an a here, your first coefficient, having that greater than 1 doesn't make this any harder or any different in the method that you follow. So we group this. So from the first group, instead of just being able to pull out an x squared, we can actually pull out a 4x squared, which is going to leave us with an x plus 4. And from the second group, we could pull out a -9, which will also leave us with an x plus 4. So still factorable by grouping. And we can pull out an x plus 4. From the first one, we're left with 4x squared. And from the second group, we're left with a -9. And once again, you're going to look to see if we have a difference of squares. So the x plus 4, it doesn't have any squares. So we're not going to be able to use difference of squares there. This second term we can, this 4x squared minus 9. 4x squared is a perfect square. It's 2x. So we have 2x plus 3 and 2x minus 3. Okay. So this is factor by grouping. That's it.